Hello and welcome. I'm Ben from Digi Technical Support. In this video I'm going to show you how to configure your Digi Accelerated Linux router for TCP to serial comms. For this demo I'm using the iX30 router with firmware 23.6.1.105 and the serial connection is made to a WR44 router with RS232 interface. TCP to serial is often used for out-of-band access to other comms equipment. For example, another router or switch that you need access to without using the company's main WAN link. Another use case is that you might have a PLC or telemetry device connected to the serial interface and you need to be able to control or monitor that device. Just for reference, the iX30 serial interface is a DTE and the WR44 serial interface is a DCE. A straight-through serial cable has been used to connect the two. If the connected device was also a DTE, you would need to use a crossover or null modem serial cable. The first task is to set up the serial port. Navigate to System, Device Configuration. When the configuration options appear, navigate to Serial, Port 1. The first task is to set up the serial port. The serial mode that we need here is Remote Access. The other options there are shown. We can give it a friendly name and then set the baud rate to match the connected device. I know the WR44 uses 115200, 8 non-1 with no flow control, so the following options are all correct. The escape sequence should be removed. This will ensure that the TCP serial connection is not closed by any characters that are sent by the connected device. The history size should also be set to 0. The idle timer can be removed. We're not going to be using an idle timer for this scenario. And if you have the option, the electrical signaling mode should be set to match the connected device. So here I know that the connected device is using RS232. Scroll down to see the other options. The next configuration task will depend on how you are going to connect to the router. The options you have here are TCP connection, SSH connection and Telnet connection. Let's have a look at TCP connection first. The benefit of using TCP is that you don't necessarily need to authenticate first. The client will open a TCP connection which is terminated on the DAL router and then the encapsulated data is immediately passed directly to the serial device. By default, TCP will listen on port 4001 and the options you have here are encrypted, which will use TLS, or a raw TCP connection, which is no encryption. If you were to choose encrypted with authentication, then you would have to authenticate using your DAL credentials first. So the main reason for choosing TCP connection would be to use encryption or raw without authenticating on the DAL router first. The next option, SSH, listens by default on port 3001, and this is the option we're going to enable. The next option is Telnet. This listens by default on port 2001. The option below here, Auto Connect, allows you to configure the DAL router so it initiates a connection outbound to a listening server. For the connection type, you have the same options. Going back to SSH, there is an access control list option on every item we've looked at. If I expand the access control list, you can see there are options for zones, interfaces, and IP addresses, and they are all blank. SSH connections will be allowed on the LAN interfaces and WAN interfaces without restriction. If you need to add restrictions and create an access control list, just be aware that the ACL uses the OR operator. So any of the configured conditions, for example an IP address, or a range of IP addresses, or a zone, or an interface that match, will allow the SSH connection through. I'm just going to enable this on port 3001 as default and apply the setting. The last configuration task is to allow the user access to the serial port, and there are two methods to do this. Go into Authentication, and then first of all into Groups, and then Admin. And you can see here that Admin does not have access to the serial port. The serial group does have access to the serial port by default. So what you can do is go into Users, pick your user, into the groups, and add the serial group for that user, allowing them access to serial port 1. This would be my recommended method. The alternative method would be to add serial access into the admin user group, like shown. I'm going to remove that and just go with the user configuration, adding the serial group into the user that will be logging in. Now I'm happy with that. Click Apply. To test this, use your favourite terminal emulator. For this demo, I'm going to use PuTTY. You can see there that I'm going to open a connection to 172.17.0.30 on port 3001, and the connection type I'm using is SSH. So I'll click Open, and I'm asked if I accept the fingerprint. Do I recognise this? Is this the correct device? Yes, it is. And then I need to log in using my DAL credentials. So I should now be connected to the serial port. Notice there's no feedback after logging in. If I type in a command that should be recognised by the connected device, for example, AT, and press enter, I get an OK, so that's good. I can do ATI5, which should give me the hardware and firmware build of the connected device. And this is a command that's being run on the WR44 itself. I can also check the status of the serial connection by going to Status, Serial, and you can see there that the status says connected. The user is an SSH user, and also there's bytes transmitted and received. So that's a good way of being able to debug if there are any comms problems. So if you see packets in the TX side, but not the RX side, you know that there's a problem on the connection between the two devices. So this all looks good, and that concludes this demo. I hope you found this useful, and thank you for watching. For more information on this or any other feature of your Digi Accelerated Linux router, please see the support pages at digi.com/support.